videos a little bit of an experiment about teaching and recording at the same time. So in your book you should have adding fractions, which is our exercise 4E. Okay, so when we're adding fractions, there's a couple of different ways that we can do this. The easiest one is when you have the same, writing this down at the same time as me please. Whoops, spelling mistake. Denominators. Already mucked it up. It's okay. Same denominators. Just add the numerators. Okay, they're the easiest kinds of questions, like a real gift if you get one of these in your exam. So for example, e.g., let's say I have 3/7 plus 1/7. My denominators are the same, they're both 7, so my answer is 4, just add across the top. And my denominator doesn't change, that's really important, so that stays the same. Okay, the very last step you then need to just make sure you do is simplify your answer. So here we've got 4/7. Can we simplify that anymore? You can answer if you want. Yeah. No, you can't, that's right. Okay, so let's say I had slightly different, I had 3/8 and 1/8 adding together. Then that would become firstly 4/8, just add across the top because my denominator is the same. And we know we can simplify that by dividing by with our, what do we call it?
LCD.
Nope, not LCD.
Lowest common denominator.
What do we use? What's this for representing?
Numerator.
Highest
Denominator.
common factor. We got there. Okay, and that would become, thanks guys, and that would become 1/2 in this example. Okay, I'll just give you a second to catch up. Okay, so this is the second part of my video, and I've titled it Adding Unlike Fractions, Part 1. I'm going to do Part 2 a little bit later, and that's to do with mixed numbers, but this part is just about adding unlike fractions. And what I mean by that is different denominators. So one of the golden rules of adding and or subtracting fractions is that you have to have the same denominators first before you add or subtract. You cannot add or subtract until you do that. Okay, so from experience, what do we know we have to do to be able to make denominators be the same? We can't just make up a new fraction. That would be not the right thing to do. Yes, Tim? Great comment. You can make them smaller or larger so long as they are the same. Let's say we're going to make them larger.
Then one way to do it is to times the two denominators by each other.
Yep.
And then you would times, so say it's 2/7 and like
I'll give you an example. I'll give you an example that we're going to work with and you can talk me through that one. So let's say we have 1/5 and plus 1/2. Okay, talk me through that, Tim.
So then you would times the 5 and the 2 and you would get 10.
Yep.
And then you would times the 1 that's on top of the 5 by 2.
Yes, why?
Because when you times the denominator by another number, the numerator also has to be done.
Yeah, so you've got to do the same to the top and bottom. Please continue.
So that would be 2
Yep.
over 10.
Yep.
And the other one you need to times it by 5.
Yep.
And that would be 5 over 10.
Beautiful. Okay, so we are, whatever we do to a denominator, we do to our numerator the same, okay, on each side. So now we have found what sort of fractions. The second set of fractions is, Ethan?
Like the denominator is the
Same. What do we use when we talk about maths when something is the same but different size? Not equal, equivalent. Beautiful. So these are equivalent fractions to these. They're actually the same size but the numbers are different. Okay, so now that we've done that, we just do what we did up here. So we just add across the top. Our denominators stay the same. So now I have 2 plus 5, 7 over our new denominator of 10. Same as in the question. Can I simplify that any further?
No.
No, I can't. So that is my simplest answer. Okay? So the steps are same denominators first. That's number 1. Convert to find equivalent if you need to. Okay? Then, as we did before, add numerators. Denominator the same. And then simplify if you can. So I'll put a question mark in brackets there because sometimes you don't need to or you can't in your answer. Okay, so let's do one more example just like that. I'll leave those steps on there so we can see. 3/4. Can I get everyone to write this down in their book, please? Plus 5/6. Okay, so first thing, check, are the denominators the same? No, they're not. So we need to find our lowest common multiple. So Tim mentioned before you can times them by each other. Yes, you can do that, and you will always be able to do that as a backup. But there's actually a number that is a multiple of 4 and 6 that is smaller than if I was to times them by each other. And that just makes it a little simpler for us, smaller numbers. Harvey?
24.
Smaller than that, 12. 24 is at times by it, yeah. So we've got our new denominator of 12. Okay, so to times 4 with something to give it 12s, I've times by 3. So do the same to the top. Okay, so that new fraction will be 9/12. That's an equivalent fraction to 3/4. And then to work with my 6 now, I've times it by 2 to get to 12. So I do the same to the top. And my new fraction is 10. Okay, now I can add these together. Just the top though, remember the denominator stays the same. So I have 19/12. Please let me know if I make a mistake. I'm trying to do a lot of things in my brain at the same time. Okay? Now that I've done that, can I simplify it?
Yes.
Yes.
Yes, I can. Patty, do you want to tell me how?
So you figure out how many times 19 goes into 12. It goes in once.
Oh, the way around, 12 into 19. Yep.
Oh yeah.
One time.
19. And then you have 7 remainder. So 7 becomes your numerator, and 12 stays your denominator.
Beautiful. Now, final step is just to have a look at this fraction part with mixed numbers and double check that I can't simplify that as well. How good is my timing? Correct. See you later.